Hello YouTube, welcome back to another video. In the last one we went over configurations where we essentially talked about having multiple projects in one folder or one repo, however you want to put it, modifying different things like our default output, buffer assets. We could modify the editor itself, which we found out. And then if you wanted to modify like a proxy, for example, or other things, we can do that as well. In this video, we're going to go over components. So if I click over here, components include things like code, Latex, Bezier Curves, Spline, Path, custom components, and code blocks. We're going to cover all of this in one video, so I hope you're ready. The first one is code. We can see there. And code allows us to display code in our animations. We're all developers at the end of the day, so I'm sure we want to show how to do different code. The code node is used to display code snippets. It supports different highlighting and a handful of different methods for animation. So if I click on code, this gives us an example of what it would look like. So first we have the code right here, function hello, and then we want to change the code from hello to now warn hello world, and you can see just the parts that are modified are changing, and then we have it back to what it originally was. So the first thing is we want, if you just copy any of the snippets in this tutorial, notice that the displayed code has a uniform color. The default highlighter uses laser. Oh, I guess this is kind of a parser. I guess that is used to parse code, but do not need the grammar for the language you're using. You can set that up in the project configurations. I guess we have to install the kind of grammar that we want. This is available grammars. So C++, CSS, Clojure, Go, HTML, Java, JavaScript, Julia, JSON, Markdown, PHP, Python, Rust, Sass, XML, and YAML. So I don't see Rust here. Oh, I guess I do have Rust. These seems like all the major programming languages nowadays. No assembly though. Add it to this file. Yeah. So it looks like it uses this parser to actually incorporate it. Very cool. So in this example, we're going to use JavaScript. And we'd have a parser. And then code.default highlighter, laser highlighter parser. And then we don't export code somehow. Okay. Then we do code. Okay, so then this, let's see. So we can have parser for all of JavaScript, it seems, or if we wanted, so it doesn't support JSX or TypeScript. You can enable these via dialects. Okay. So if we wanted to turn on a dialect, we would. And that's how we would do it. And then to define code, font size, code equals, and then our string. We saw up here that if we do a backtick and then a slash, or a tick and a slash, slanted tick, we can have multi-line. But if we just have a up and down tick, then it would be not multi-line. Oh, and this just talks about it ourselves, what we just talked about. Ignores indentation of the template string itself. The template string preserves all white space characters, so any additional spaces or tabs at the beginning of each word would be included in the snippet. So this is the same as this, I assume. And then we can have different variables. So name is number. And then we can say is any valid JavaScript expression inside that syntax will be included in the code snippet. Okay. Using signals. So we can do code. Create signal for number. And then name signal. So the new signal, it will display number instead of new value. Trying to pass this in without invoking it is even worse, since each signal is a function. It will be stringified and included in the snippet. Okay. Oh, okay. So name snippet signal. Here we have it as a function. We don't want it as a function. We want it as the variable itself. And so if we have it as the variable itself, you'll see number, and then we'll use the variable or the function call to replace it with new value, and that's what we do down here. Okay, I got that. Now it's updating as we would expect it to. The return value per code can itself be nested into other template strings. So that's what the code right here is for, is a template string. So implementation is a template string. Implementation is put inside of greet, which is then put inside of method. And then when we have class with a K, we are actually showing the whole thing. That's interesting. And we can animate the code. The different methods for animating the code is called diffing. It is used whenever you tween the code property. Okay, so we have to show the code at all times what we want it to be. And it looks like code, then we want to change it, so this would be the tween. This code is different than this code because this code represents the ref. This code is a function that you can do, or property that we can modify of the code type ref. We're putting it back and forth, and then we can do append and prepend. So code append. So 1, 2, and 3. So this is the first one that happens. Then we want to append a new line and then add 2. Then after some time, put no more. This is missing some things, but this is using the signal signature. This is using a template tag signature. It's a little bit different way of doing the notation. My preference is signal, but if you want to do template tag, you can do that as well. And then we can also prepend instead. insert, replace, and remove. So insert code in line 2. So for part is return the 7. So line 0, 1, 2. So it'd be replace in where this line normally is. I'd want to put return 7. There's a space here, which is why there's a space here. We want to start this at column 0, which is why there's a space here. And then we want to return that. And then replace the word hello with goodbye. So hello, line 1. So we have 0, 1. 15 characters in. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's the 15th character. And then we go 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4. Yeah, that's 6 characters right there. So starting at character 15 with an index of 0, replace the 6 characters there. So hello and the exclamation mark, and replace it with what? Goodbye. Remove line 2. So this line that we put in, we want to remove it now. Animate the changes at the same time. So greet and hello would get modified at the same time, and then we wait for 6.6. So that sounds good. Edit method offers a different way of defining code transitions. Is used together with replace and insert and remove helper functions that are inserted into the template string. They let you specify the changes in a more visual way without having to know the exact position in the code. So this is a comment. Oh, this is messy. So we have this. We're modifying the code. We're adding, this is a comment. We're removing 7, and we're replacing hello with goodbye. Okay. That's how we would edit it. Then we have signals, which we already really talked about. Message, create signal, hello world. Here we have another signal, console log message. So that message lives inside of here. This body lives inside of here. Message, we're replacing hello world with goodbye world. And we are appending to the body return 7. So this is another way of modifying code if you wanted to. Lots of ways to modify code. I will say that. Here's an example using nested strings. Code range. So start. Okay, so this is what we already talked about, or we figured out. Start line, start column, end line, end column. For convenience, the word and line helper functions provide to create some of the common types of ranges. So we got a word, line, and line. We have some more helper functions: find first range, find all range, last range, code selection. Okay, so if we wanted to point out something, if we were talking about it, we could use selection. So hello, global, or select the first line. And that just kind of highlights it and darkens everything else. and then putting it back to the way it was. That's will be very useful in the future for me, definitely. Querying positions and sizes. So we are find first range, log get selection box for range. So it looks like code add rectangle, and then range position, range size. So what it looks like we're doing is we're finding the location of log. So we're getting a selection box. We are expanding upon that and placing a rectangle at its position, so that if we wanted to put a rectangle over something that we were really wanting to specify, this would be a good example. You could also change it from a rectangle to just a line if you wanted to underline something. The world has endless possibilities. And then there's custom themes as well. Looks like multiple languages. So we have a Rust highlighter, which is right here. So view add, this code is using the default, which is which would be Node.js from what we talked about in the very beginning. But now we're wanting to add another highlighter if we wanted to, and that's going to be Rust. And then if we wanted to make the Rust, let's see, it is useful to create custom components for languages you use often. So source node rustcode.ts. And then this basically does all of this magical stuff up here. We put it into one file. Now we can export Rust code and just say, hey, here's a Rust code, instead of having to do this over and over and over again, which is pretty cool. This kind of shows easier ways of doing things, so you don't have to have all this boilerplate code. You can just make your own JSX objects. And rendering. If you're using a Chromium-based browser, you might notice that the code animations jitter a bit. This happens because Canvas snaps the rendered text to the nearest pixel, which prevents it from moving smoothly. Until we find a way to fix this, we recommend using Firefox for rendering. Lucky for us, all of these tutorials are using Firefox. I am a Chrome user, but we are using Firefox for this. And then we have code grammars, and this is the list of grammars that we looked at already. Next, for components, we have Latex. So this would be used for any sort of mathematical equations. So we can see it's a special kind of format. So this right here gets mapped to this. You can see Latex in other animation things like Manim, which is a Python-based animation library, also supports this. It's nice that Motion Canvas does. It opens up the possibility and allows us to do different things, as in there's one for doing sheet music. So if you wanted to do Motion Canvas animations based on different sheet music, you would be doing it based on this kind of notation. You can also animate it. It's like 1 + 1 = 3. So if you were doing some sort of math tutorial, you could probably do 1 + 1 and then leave that blank and then change that to =3. And there's different ways of doing the animations. as well, or different formats that you can use. Okay. So this was the 1 plus 2, and then they're changing it to 2 plus 3 plus 4. Common pitfalls. The backslash character is used to escape characters in JavaScript. In order for it to be part of the formula, you need to escape it by doubling it. This does not apply inside of a JSX string attribute. So you can have the, what is this? Oh, they're missing one, because this goes here. Yeah, they're missing a closing bracket in this example, but there's no escape necessary. If you do have it, the JSX way of doing things, you would need to escape it, and they don't. This is a bad example. And then we have missing spaces. And yeah. Then we have Bezier curves, which are just fun type of curves that can really draw any shape. And so I'm not going to go into really what these kind of curves are from a mathematical standpoint, but just know that if you want to use them, you can. 0.1, 0.2, 0, 1, 2, and 3, I believe. And the curve just follows that. All curves are compound signals. This means it's possible to animate their x and y components. Then we have arrows, start arrow, end arrow, arrow size. We're modifying the arrow size in this example. Quad Bezier. Oh, this is an example of it being created, which I think is pretty cool. Cool. And then next we have a spline. It allows us to draw and animate smooth curves through a series of control points, such as a beating heart. So if we look at this, we can see that we have our spline, a knot. Don't know what a knot really is. Let's see. Knot. Really not of a spline. Doesn't really help. Here's the, I was looking at this example. So we have a closed off spline. So I'm guessing this is just multiple components. So if I were to guess, it would be like going up to here, down to here, down over to here, and back here. So the different components of the heart is what I'm guessing. And then we're scaling it, the whole object itself. So I think that's how it's able to get it. The spline component allows us to draw and animate smooth curves through a series of control points. If all you want to do is draw simple Bezier curves, check out the curve component instead. Using the points properties, so it's very similar to a Bezier curve. Only with this, you can have more control over like the kind of smoothness you want. And then using knot nodes, the second way of defining a knot is by fitting using the knot node. The same spine from above can be written like this. So we have the different knots, and that represents this over here. So we can see the different points, so negative 300 to 0, negative 300 to 0, and then all the other ones are broken up into that. So we can either do this or an array. Both should work. And as you can see, we get the exact same shape as we did with the point property event. Property advantage by defining the knots with knot nodes is that it allows us to control the position of each knot handled via start and end. And if we do that, we can do weird looking loops as well. Note that the handle positions are relative to the knot's position. We can also do nearer. We can do broken. So this is cool. Using the knots, we can make different shapes like D, for example, or A, or whatever we wanted. Blending between the two different notations. Oh, that's cool. So yeah, maybe if there was video about like different like Asian characters or Norse runes, or like how different shapes morph into other shapes, or different older characters morph into more modern day Latin based characters. If you want to do like a history video of that, you might want to use something like this. This is pretty cool. We also have animating the spline. Animating the knots of the spline. So we have a knot array, knot, make ref. So I think here we have an array, and instead of putting the array in the spline, we're making an array of the different knots, and now we're controlling each of the different components individually. If you really wanted to do this, you could. Don't know why you would. Then you can animate an object along the spline. So we have the spline with the different points, and then a rectangle, position, get point at percentage, progress, dot position. So spline uses this reference, and then rotation, it would be tangent to it. Okay, we're learning a lot in this video. We're learning a whole lot. Next we have path. How many more components are there? Okay, we have path, custom components, and code blocks next. So path, similar kind of like we did before. They're great for displaying SVGs, but the format can be confusing if you want to have more intuitive control of the path and each control point within Motion Canvas. We recommend checking out the spline component. For a different path, yeah, that's definitely a SVG. Yeah, I think in a future video, I'm going to talk about the SVG format. Let me write that down in my notes real quick. Okay, I think I got that captured now. So we have, there's our data, which creates that triangle, animating paths. So we would have this path turn into that path. It's kind of fascinating. I don't know how they're doing this behind the scenes, but that's wizardry. And then we have this path, and then we're again animating our object around it. Remember to use the tangent for degrees and position. Custom components. So this looks like a pretty cool light switch. So we have a switch which comes from a custom component, and then we either have true or false, and then we have toggle to toggle it true or false. This would be example source components switch. So components switch. So this is what it would be like for our switch components. We have our rectangle and circle, toggle, they are changing the position and going back and forth. Fascinating. So components in are classes like rectangle and circles that can be abstracted using rendering and data functionality into reusable modular pieces. This to use a component in a scene, add it to the view, and provide arguments to the component. So we have switch initial state false, and we use signals and other things to set it all up correctly. So yeah, if you want to learn more about how that one is done, I would recommend having yourself go to this page. But this will be a good reference in the future. And then they have that notation, which I didn't even know was in Node.js. But it is, it looks like. And there's your switch or conductor, rectangle, circle. And we have our toggle. And then this is the full guide, which is a lot. But it's very interesting how they were able to put everything that we've learned together so far into this. Cool. Then we have code block. Code block has been depreciated. So I won't be going over code block itself. If you want to do anything with code, make sure you use the code node, which we talked about in the first part of this video. In the next video, I'll be going over all of the advanced stuff, similar to how I combined all of components into this video. I'll be combining all of advanced into the next video. If you enjoyed this series, please hit the subscribe button, like the video, and I'll see you in the next one. Until then, have a good day.